This is the second largest moon in our entire solar system, bigger than the planet Mercury. But size is only the beginning, and what we've discovered here is nothing short of extraordinary. Welcome to Titan, Saturn's largest moon, a place so strange that when scientists first saw its data, they were forced to rewrite textbooks. Titan is a moon with an atmosphere thicker than Earth's, rivers not of water but of methane, lakes that mirror the sky, and chemistry that defies everything we know about how planets should behave. So, let's find out what's really happening on Titan. Titan isn't just another moon. It's bigger than Mercury. And it might be one of the strangest worlds we've ever found. In the grand scale of our solar system's moons, but size is only the beginning of what makes Titan fascinating. Unlike almost every other moon, Titan has a thick atmosphere, one composed mostly of nitrogen, like Earth's, but much denser. This atmosphere obscures its surface so completely that early telescopes only saw a fuzzy orange glow. For decades, scientists puzzled over this foggy world. Were there oceans beneath? Could there be volcanic activity? Could life of some kind find a foothold here? The questions piled up. But here's where things get crazy. In 2004, the Cassini spacecraft, a joint mission between NASA, ESA, and the Italian Space Agency, began orbiting Saturn. For years, it made repeated flybys of Titan, probing its atmosphere and surface with radar that could see through the haze. What Cassini found shocked scientists. Titan wasn't a frozen, lifeless rock. It had weather. First, Titan wasn't a frozen, lifeless rock. It was a world with weather. It had clouds, winds, rainfall, dunes, rivers, and lakes. But these weren't like anything on Earth. On Earth, rain falls from clouds as water. On Titan, it falls as liquid methane, a gas on Earth. Rivers wind across the surface, carving channels like the Colorado River, but instead of water rushing past, it's methane flowing in icy cold. Lakes of liquid hydrocarbons, methane and ethane, pool near the poles in basins thousands of kilometers wide. The largest of these seas, Kraken Mare, is vast enough to rival the Great Lakes of North America. But rather than water, Kraken Mare is dark, liquid methane reflecting Titan's golden sky. This was not just discovery, it was transformation. In 2005, the Huygens probe became the first human-made craft to descend through Titan's thick, golden atmosphere. Suspended on parachutes, it drifted slowly through a haze that had hidden the moon's secrets for centuries, sending back historic images and data that would transform our understanding of this alien world. As it fell, Huygens revealed a landscape both familiar and strange. Rugged hills, river channels, and dark patches suggested flowing liquids, not water, but methane and ethane, shaping the surface over millennia. Its instruments measured a nitrogen-rich atmosphere alive with complex organic molecules, hinting at prebiotic chemistry. Winds whispered through the clouds, and subtle currents in the atmosphere revealed a dynamic, ever-changing world. For the first time, we saw that Titan was not a frozen wasteland. It was alive in its own alien way, sculpted by winds, rains, and chemical reactions. Yet Huygens only gave us a glimpse. Questions remained. How deep are the hydrocarbon lakes? Could subsurface water pockets host the precursors to life? Huygens was humanity's first handshake with Titan, a mysterious, dynamic moon, inviting exploration, curiosity, and imagination, and paving the way for future missions like Dragonfly to unravel its secrets. For a long time, scientists assumed that Titan, like other icy worlds, must hide a global ocean of liquid water beneath its frozen shell, perhaps warmed by tidal forces from Saturn's gravity. After all, similar oceans are believed to exist beneath Jupiter's moon Europa and Saturn's moon Enceladus. and those worlds are prime targets in the search for extraterrestrial life. But new research from 2025 upended that assumption. Rather than a vast, interconnected ocean, Titan's interior might be a complex maze of thick ice, slushy layers, and pockets of liquid water, but not a single global sea. These pockets may be warmer and more dynamic than the surface suggests, but they are hidden deep beneath kilometers of ice. The model suggests that instead of a simple ocean, Titan's interior is more like a layered onion: ice, slush, ice, pockets of liquid. And at the deepest levels, pressure and tidal forces could create environments that are surprisingly dynamic. This doesn't rule out the possibility of life, far from it. In fact, the presence of isolated liquid pockets might make Titan's interior more chemically diverse than a uniform ocean. Each pocket could be a unique experiment in chemistry, secluded and different. Titan's mysteries have inspired one of the most ambitious planetary missions ever conceived, Dragonfly. Slated for launch in 2028 and due to arrive at Titan in 2034, Dragonfly is not just another lander. It's a rotorcraft, a flying robotic explorer capable of lifting off and traveling dozens of kilometers between sites. Powered by a radioisotope generator, Dragonfly will explore multiple terrains, from hydrocarbon dunes to impact craters, in search of chemical clues about Titan's past and present. Why a flying machine? Because Titan's dense atmosphere and low gravity make flight surprisingly efficient, and because some of the most interesting chemistry might lie far apart, in regions unreachable by a simple rover. Dragonfly will carry instruments to analyze organic compounds, atmospheric particles, and surface materials that could be the key to understanding Titan's complex chemistry. Scientists hope this mission will shed light on whether environments like Titan's could ever, in some form, support life. Titan's sunlight is faint and distant, filtered through a thick orange haze. Its seas are not made of water, but of liquid methane and ethane, hydrocarbons that would be gases on our world. And yet, the more we learn about Titan, the more it transforms from a frozen, alien moon into something far more intriguing: a natural laboratory of astonishing possibilities. Titan's atmosphere is rich with complex organic molecules, the fundamental building blocks of life, reacting and evolving in ways that Earth chemistry rarely allows. On its surface, methane flows through rivers, gathers in vast lakes, evaporates into clouds, and falls again as rain, forming a complete and active liquid cycle eerily similar to Earth's water cycle. Winds sculpt massive dunes across icy plains, seasons shift over years, and weather patterns reshape the landscape. Beneath its frozen crust, scientists suspect hidden pockets of liquid water, insulated from the brutal cold above, environments that could host unexpected chemistry. With NASA's Dragonfly mission preparing to explore this mysterious world up close, Titan transforms the way we think about habitability. It asks us, does life require water as we know it, or could it emerge in other solvents? Can chemistry organize itself in ways we haven't yet imagined? Is life defined by biology or by a process we've yet to recognize? Titan doesn't just challenge scientific assumptions. It invites us to imagine a broader, richer universe where life might not be limited to Earth-like environments. It is a world where the familiar and unfamiliar dance together. Rivers that flow not with water, but with methane. Chemistry that defies textbook rules. Environments hidden deep beneath the ice, and a sky that glows gold in perpetual mystery. Titan is not a footnote in planetary science. It is a cosmic mystery waiting to be understood, a place where every discovery raises a dozen new questions, and where exploration itself becomes an adventure into the unknown. So if you like this dive, smash that like button, share it with your friends, and subscribe for more out-of-this-world science. See you in the next adventure.